So this episode is about solving half-life problems. There may be one or two questions on your regent or your final regarding this. Now, anything to do with math, just keep in mind, my math is probably different than your math, and there's probably an easier way to look at it without even doing a math problem. Okay, so we're going to do a couple of examples, one from each of the subsections, just so you kind of get a feel for what's going on here. Now, if you remember anything from your earth science days, half-life is basically a constant. It's never going to change. That just means the amount of time that it takes for exactly half the sample to go away or decay into something that's more stable is how we're going with this. Also, keep close with you Table N, which are all about your time that it takes, your half-life for each of the isotopes that are given. And again, you might see this word nuclide. Just keep in mind that's a term that just means radioactive isotope. And more likely than not, you're going to be utilizing these terms with Table N. All right, so let's take a look at it. Here are two math equations that you could potentially use, but I'll try to show you as easily as possible how to do them without doing math. Okay. So the easiest way to do it is that every time I draw an arrow, that's going to represent one half-life. So if I take a look at number 1, where it says, how long will it take for 30 grams of radon-222 to decay into 7.5 grams? So this is pretty easy. Okay, so you right with what you start. And I draw an arrow. What's half of 30? 15. What's half of 15? 7.5. So every arrow that I drew was 1 half-life, and this is going to be 2 half-lives. So in total, it took 2 half-lives for this to occur. So how long is that for real? Find your nuclide. You see that it's 3.823 days. So 3.823 days. And you're going to multiply that by 2. And the total time it took is 2 times 3.823. So that's how you would basically do for the time elapsed. The next part is about time remaining, or excuse me, amount remaining rather. So let's take a look at number 6. How many grams of nitrogen-16 will be left from a 16-gram sample after 21.6 seconds? So there's a couple of different ways we can do this. Okay, we can continue with the very simple arrow trick, which I'll show you. If we started with 16 grams, okay, we know there's going to be a half-life, but we don't know what the half-life is going to be just yet. So there is an equation to figure that out. That equation is going to be the half-lives, number of half-lives, equals little t over big T. Big T stands for the half-time, or the half-life time it takes for half the sample to decay, and the little t is the total time that's elapsed. So let's take a look here. We have nitrogen 16, which is right here. Okay. One half-life is 7.13 seconds. Okay, so let me just write this. Half-life is 7.13 seconds. So this is asking how much is going to be left in 21.6 seconds. So there's a couple things I can do. I can figure out, well, how many times does 7 go into 21? And that's roughly about 3 times. So I did that by taking the big T, which is the half-life, or excuse me, the big T, which is, total time elapsed, which is 21.6 seconds over 7.13 seconds. And that's going to get me number of half-lives, so that's 3. So I'm going to draw 3 arrows. If I start at 16, I'm now at 8, I'm now at 4, I'm now at 2. And it's a good thing to kind of carry over the units just so you know specifically what we're trying to display there. Okay, how much is remaining? So fraction remaining. We can do this a number of different ways. Okay. Let me show you the equation for this one. Okay. As you can see, 1/2 is a fraction, and I have little t over big T. Big T is the half-life time, and then little t is the total amount of time. So let's see if we can try to figure this out with potentially what we have here. So what fraction is going to be remaining of a 100-gram sample of potassium-42, where the half-life is 12.36 hours. Okay. And total amount, which is little t, is going to be 24.8 hours. So first I have to find my half-life. To do that, I take my little t divided by my big T. So my half-life is going to equal 2. And if I'm starting at 100, I draw my 2 arrows. Half of 100 is 50, half of 50 is 25. But what it's asking here is a fraction. So what you do is you take the last number and divide it by the first number, and you multiply that by 100. And that's going to be 25%, or 1/4. So either one, they might ask you as a fraction. So here's the fraction. They might ask you as a percentage, and there's your percentage. You might be asked how to figure out the number of half-lives, which is kind of what we've been doing here, except we have to figure out how many arrows we're going to draw instead. So how many half-lives will it take for 50 grams, so I have a mass, 50 grams of TC99, which is 2.13 times 10 to the 5 years, and that's my big T, that's my time it takes in my half-life. And it's looking like we have to go all the way down to 6.25. So we can do it as simple as this. We can map it out. 50 to 25. Half of 25 is 12.5. Half of 12.5 is 6.25. How many half-lives? 1, 2, 3. And the last process that you'll be able to do is to figure out what the original mass was by using all of these different processes to figure it out. So 2 grams of an original sample is left. So I'm going to put 2 grams all the way over here after 13.45 days. So my total time is 13.45 days, and my half-life of gold 198 is 2.695 days. And if you roughly do the math, it's probably about 6. So my half-life is going to be 6 of them. So I'm going to draw 6 arrows, but I'm going to do it in this direction. 1, 2, 3, 4, 5, 6. So 2 is really 4, which is really 8, 16, 32, 64, 128. That's my original grams.